In this video, we're going to talk about how we can best debug our Node.js applications. So we'll talk about some debugging strategies, and we'll also explore the debugging tools that Node provides you to make it much easier to fix your broken apps. We'll be exploring the Node debugger, which integrates directly with the Chrome developer tools, giving you a nice GUI for debugging your backend applications. It's a really great way to figure out why your app's not working. Now, in general, there are two types of errors we're going to run into when working with Node.js. We're going to have things go wrong, and we're going to get an explicit error message. So we've already seen that when we've made typos in the class. And the other type of error is when things go wrong and there is no error message, which likely means we have some sort of logic problem in our code that we're going to need to first figure out where it is, and then second, adjust to make it actually work. Now, we can employ these same strategies for debugging both types of errors, so let's kick things off by exploring some of the basic tools that Node provides. The most basic debugging tool we have is something we've already used dozens of times before, console.log. So let's say that for some reason this message never seems to print. Even when I try to add a duplicate, I'm not getting note title taken printing. What would I do to fix this? The first thing I would do is look at the contents of duplicate note right here to make sure it's what I'm expecting it to be. So what would I do? Well, I could just use console.log. I could print out the duplicate note variable, allowing me to see its value when I run the program. Now, console.log might get a bad reputation on medium.com posts where they say you should never use console.log for debugging. I think that's all overblown. Everyone wants things to be black and white. This is the only way, that way is bad. And in general, it's all about finding the right tool for the job. I use console.log all the time in client projects to quickly just dump a value to the terminal so I can check it out. Right here, we could now run the application to dump that and see what's going on. So I could do something like run node app.js using the add command. I'll provide a title for my new note. Let's go ahead and set it equal to something like courses. Then I'll go ahead and I will create a body option as well, setting that equal to something like Node.js. Perfect. So we have our new note being added, and as that program runs, we're going to be able to see the value of duplicate note. When we run it here, I can see it's undefined, which is good. When I run it again, I can see now the duplicate has been found and we're getting that printed. So hopefully we would be able to use that information to figure out what's up. Now, if not, we would want to take things one step further. If duplicate note is bad, that means either the notes array isn't what we're expecting, or maybe the title argument isn't what we are expecting. So what do we do from there? We continue to log things. So I could console.log something like title, and I could even console.log notes down below. If I were to rerun the program, we now get even more information, making sure we can figure out exactly why our application is running the way it is. Now, console.log is great for a lot of situations, but if you find yourself logging out 5 or 6 or 7 different values, it can really become a burden. It can be annoying to add all of those console.logs around your program, then remember where you put them and actually remove them. So console.log is the most basic tool available to us for debugging our apps. Next up is the Node debugger, and that is Node's built-in debugging tool, which integrates with V8 and the Chrome browser. The debugger, like console.log, needs to be added at a specific point in your application. So let's say that right here, once again, I want to explore the variable values at this point in time. If I want to pause the program here, I can use debugger. That's going to stop the application at this point in time. Then I can use the developer tools, which we'll see in a second, to look at any values I want. I could look at notes or duplicate note or title or body or anything else that existed. And obviously, this gives us a bit more flexibility. With console.log, we have to manually list out the things we want to see. With debugger, we can just add the debugger statement one time. And once we get to the dev tools, we can look at everything. Now, with this in place, our application isn't going to change how it runs by default. Down below, I'm going to rerun the command I ran before. It is indeed going to pass through this line of code, but what happens? Nothing happens. We just see our message, which comes from the line down here. So this line ran, which means that this line definitely ran, but the program didn't stop. When we have debuggers in our application, they're not going to pause the program by default. We have to run node with a special option to get that done. And to do this, we use node followed by inspect. So node inspect, then we add everything we would normally add. So I could add the script name, app.js, like so. And in this case, I can also add my command line arguments afterwards. So I could set up the add command. I will provide a value for title. I'll use courses once again. And I'll also provide a value for body once again using Node.js. So now, by just adding inspect in there and running the script, we're going to get much different output. This is Andrew from the future with a quick update. So as we run that command, some of you running on Windows, you're going to get an error. You're going to get the error that we're seeing here. So right here on the screen, I have two commands. I have the command we just ran up top, and I have an alternative command down below. Now, as you run that first command, you might get the error that's shown just below it. Right here, that is timeout 2000, waiting on 127.0.0.1 on port 9229 to be free. So if you run the command that we just typed out and you get that error, this update is for you. So I've been digging around a bit in the issues, and this is an actual problem, which means that there's not something we can really do on our machines to fix this. We have to wait for a fix to be released, then we can install a new version of Node, and hopefully things start to work. For now though, if you are running into that error, the second command down below, that should allow you to continue on exactly as we're seeing in the video. The only difference is that the command's a bit different. So up top, we have node inspect. Down below, we have node space hyphen inspect hyphen brk. So brk is short for break. That second command is going to run the inspector. It's going to break on that first line, which means that we're still going to be able to use Chrome to inspect our application as it runs. So once again, this update only applies to users on Windows who are actually getting the error shown in red. If you're not getting that error, I'd recommend using the first command as it's more modern. If you are getting an error, for the moment, I'd recommend running that second command. Hopefully in the future, Node fixes this issue and I can remove this update altogether. All right, that's it for this update. If you have any questions, just open a question in the course Q&A and we'll work with you to get unstuck and back on track. See you soon. The output we're seeing here is Node letting us know that a debugger is now up and running. We can see debugger listening on, followed by this URL. Now we can head over to Chrome to actually inspect our application. Over in the Chrome browser, what I'm going to do is close down all of the open tabs I have so far. We don't need those anymore, and we're going to pull up a specific URL. It is chrome://inspect. Now remember, the Node debugger, it's using the built-in V8 debugger tools. That means that Chrome, which also uses V8, is currently the only browser we can inspect our Node applications using. So if you normally use Safari or Firefox or some other browser, you're not going to have the exact same debugger integration. I definitely recommend grabbing Chrome for the rest of the class, even if you only use it for debugging Node. Now, right here, what can we do? Well, we can see we have some stuff under remote target. Under remote target, I have two targets. I have one at the port, and then I have one at the shorthand localhost. In the end of the day, both are the exact same process. They're just duplicates. Now, if you're seeing nothing under remote target, that likely means you have a misconfiguration. Some Chrome browsers, for some reason, have altered configuration details. If you click that configure button, you should see two values inside of here. Localhost port 9229, then 127.0.0.1 on port 9229. If you don't have both of those, go ahead and add them into the mix. Then if you refresh the page, you should see the target showing up. If that still doesn't work, as always, just crack open a question in the Q&A and I'll work with you to get unstuck and back on track. Now from here, we can actually inspect our application and we can pause at that point in time. We put the debugger statement and view all of our application's variables and values. Let's get started by clicking inspect so we can actually open up a new instance of the debugger tools for debugging our Node.js application. So right here we have the Chrome developer tools, although obviously some stuff is not here. For example, we have our tabs up above. In the browser, we would have something like an elements panel. That doesn't make sense for Node since the elements panel allowed you to debug your HTML document, and we don't have an HTML document here. But we do have two very important tabs. We have the console tab and the sources tab, both of which we'll be using to debug our application. Now, there is a lot going on with this sources tab, so let's take a quick moment to break down what's happening. In the middle, we have our file, app.js, exactly as we have it over inside of Visual Studio Code, with one very important difference. You'll notice on line 1 of our program, we define the chalk variable. Over here, that does indeed happen, but there's a whole bunch of stuff added beforehand. From the very first character of line 1, all the way over here to where the const chalk is defined, this has all been added. Now, this is a function that wraps your Node.js script. So with other programming languages, you might have a main function you define. When you run the program, that's the function that starts up your application. With Node.js, we don't have that. It just runs your entire script top to bottom. So to make Node actually be able to run your program through V8, your code is wrapped in this function right here. Now, this function does indeed get closed as well. So if I scroll all the way to the bottom of the file, I can see the closing of the curly braces and the parentheses. So this function can be considered our main function of sorts, and it provides to our application a few different values we can access. We'll be exploring the others later throughout the class, but one of them is require, which we've already used extensively to load in NPM modules, Node core modules, and the other scripts we've created. Now we can actually add our project folder to the developer tools. On the left-hand side, we can get that done by clicking Add Folder to Workspace under File System. I'm going to go ahead and do just that, and I'm going to navigate to my Notes app directory. So from the desktop, I've added the Node course folder. In there, I have Notes app, which is the directory we've been working with in Visual Studio Code. I'm going to select that directory, and we can see that after we allow access to that folder, what we see changes a little bit. Right here, we no longer have that wrapping function. We just have the code we wrote exactly as we wrote it. On the left-hand side, we can even dig through the other files in our application, and we have this little green icon to show which is the currently active file. When I am debugging Node.js, I like to keep the console open as well. We can actually have both sources and console open by keeping the sources tab open and using the escape key to toggle the console. So I'm going to leave that up as well so we can view the output from our program, and we can even use this to run various commands, which we'll see a little bit later. Now, it's important to note that at this point in time, not a single line of our program has executed. Right here, line 1 is highlighted in blue. This is the line that the debugger is currently paused at. And when it's paused at a line, it hasn't executed that line yet. So we haven't even defined this chalk variable. On the right-hand side, we have a lot of information about where our program currently is. So I have information about the call stack, I have the scope we currently have access to, and up above, I have tools for working through our application. So currently, the debugger is paused. We need to go ahead and manually tell Node to continue running the application. So at this point in time, we can go ahead and do just that. What I'm going to do is click this blue play button. That's going to resume executing our script, and this is going to run until it's told otherwise. And one of the things that's going to pause it is the debugger statement, which we do have in our program. So I'm going to click play. It is going to run the script. Now you can see we are over in notes.js right here on line 8, where we defined that debugger statement. And at this point in time, we can really start to debug our program at this point in time. So over here in the call stack, we have some useful information about exactly where we are in the program. We can see we are on line 8 of notes.js in the add note function. And down below under scope, we can actually see access to the variables we have in scope. So I have duplicate note, I have notes, I have this, title, and body, and I can see all of those values right there. Now, we can always dive deeper into any of those values by running some statements from the console. So down below, for example, I could access body by typing it out. I can hit enter, and I can get that value. I could even grab something like one of the notes. So I could go ahead and reference the notes array, grabbing an item by index using my square brackets. I'll go ahead and grab the second item with the index of 1. I hit enter, and I can dump that object to the console and make sure its individual properties are what I'm expecting. So with the debugger statement, we can really dive deep into the current state of our application at that point in time, and we can figure out exactly what's not looking right and what needs to change. Now, as we run through our program, eventually we will get to the end, and that's what's going to happen if we click play again. Since we don't have any other debugger statements, it is going to work through to the end, and now we're all done. We have ran through the application, and down below, I am seeing the console.log note title taken. Now, unfortunately, Chalk can't style the output in the debugger, but that's okay, as that's just a little utility to make our applications a little nicer. It's not an essential piece to the puzzle. At this point, our application has finished, and if I close down the developer tools, I can see that on that inspect page, there is no longer a remote target available. Now, if I wanted to run through the program again and debug things, I can run a single command from the debugger in the terminal. Right here, I can run restart. That's going to start the program again. I can see I now have a new remote target, and I can inspect the application again, working through it from beginning to end, looking for whatever I happen to be looking for. Now, at some point, we're going to be all done with the inspector, and we can always shut it down by heading over to the terminal and using Control-C twice. When we do that, it's going to exit the process, bringing us back to the command line where we can do whatever we want. We could install a new NPM module, or we could run our node application without inspect if we fixed the issue we're debugging. From there, we can go ahead and remove that debugger statement, bringing our application back to the state it was when we first started. So there we go, a couple of tools we can use to debug our apps. We explored console.log as well as the debugger. In the next video, we're going to continue working through debugging. I'm excited to get to that, so let's go ahead and jump right in.